It's my pleasure to introduce and invite Anil Karmel to the stage to give us an overall look at the RightPath architecture and insight into Los Alamos' National Lab Infrastructure on Demand platform. Anil is the M&O Chief Technology Officer for NNSA and the RightPath Chief Architect for a range of enterprise IT solutions including cloud computing, mobility, unified communications, and enterprise wireless. Please join me in giving Anil a warm welcome.
Thank you, Guy, and thank you to AFCEA and industry partners for having us here and the opportunity to share our stories. So I think this morning you heard from Bob and Travis about RightPath, what are we doing, and why are we doing it. So now we'll step a little bit into architecture, talk about some of the how pieces, some of the pieces of the puzzle, and how we deliver this architectural framework, and set the stage for Chris McPherron to talk about how we secure that environment. So with that said, again, we'll start with that broad overview of those three specific pieces that we're talking about from a delivery point of view. RightPath focusing on people, processes, and technologies to deliver one voice, powered by your cloud, over the one NNSA network. So without further ado, we'll step into the architectural components that comprise the same. Mic's on. Yep. So that's on here. Oh, there we go. All right, much better. So without further ado, we'll step into your cloud and talk about the your cloud construct and what that looks like. So to level set the audience, let's start with the NIST definition of cloud computing. So the NIST definition is cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable compute resources. So with that said, what's the problem statement? Well, the problem statement is organizations are typically faced with large existing technology investments, but our budgets aren't going up, they're going down, as you heard this morning. So we need a vehicle to deliver new capabilities to our constituents with less money. Well, that's an interesting trick. So from that perspective, combine that with the fact that US data centers consume anywhere between 1.7 and 2.2% of the overall US energy budget. That is not an inconsequential number. So we need a vehicle to monitor and maintain and really quantify what are the energy consumed today and how can we save energy. As the Department of Energy, we have to be cognizant of the energy that we're consuming and have vehicles to save the same. So with that said, the slide is not advancing. There we go. Your Cloud is a cloud service broker, as you heard Travis mention earlier today. It is a portal that allows users to log in, and you'll see a bit of what that looks like, providing a service catalog for users of virtual desktops, enterprise services, and servers delivered into secure Your Cloud enclaves that are completely owned and managed by the requester. So in this case, you give sites complete autonomy to own and manage their own workloads, whether on-premise, in their own existing facilities, or via commercial cloud service providers. So this takes that existing technology investment that you have within your own data center facilities. You're able to leverage that capability. You build a private cloud using the IoD portal capability, which is being re-platformed, and also manage commercial cloud service providers. So this takes the private to hybrid, but it also takes it a step further. Because we are individual national labs, plants, and headquarters, we have a similar mission need across our community. So we're really building a secure hybrid community cloud, taking the NIST concept of hybrid and community, bringing them together to really deliver this new capability. So with that said, infrastructure on demand is the first infrastructure as a service secure hybrid cloud to automatically request and provision these virtual servers. So let's talk about some of the value-added features of IoD. Green IT smart meters. So within IoD, there is a Green IT smart meter that dynamically computes the amount of energy saved per year over time and displays that on a website. I'll show you what that looks like. There's a dynamic cost calculator that dynamically computes the cost for you based on the amount of CPU, amount of memory, amount of disk, the tier of service selected at time of provision, displayed to you before you provision the workload for both on-premise facilities and commercial cloud service provider. So you have full transparency about what that cost is before you make a purchasing decision. So as Travis was stating, that travel analogy, right? Kayak.com or Expedia.com. It's, I want to go from this place to this place at this time, go. Here's a list. Here's what makes sense for you based on the data that you're trying to manage. Where should that workload reside, and what's that cost to me? You know what that decision point is before you make that purchasing decision. So with that, you need to have something around how you manage that workload from a holistic cradle-to-grave perspective. Because the fact of the matter is, we as IT practitioners are very good at turning systems on, but we're not so good at turning them off. So the idea here is you need to have a vehicle to manage and maintain that workload, again, from cradle to grave. So within the IOD broker, you can request a server for a maximum period of 1 year, after which time you must renew the system or it will be automatically decommissioned and taken off the network. So this tells you two things. Number one, someone is carrying and feeding for the workload, because the reality of the situation is projects get spun up, people go and they provision a workload, and then projects get reprioritized, people get reprioritized, they go work on something else, and who's taking care of that workload? That would be the bad guy using that as a CNC vehicle to take over the rest of your environment. That's a bad day for you and everybody else. So from that perspective, you know from a security point of view, someone is managing and maintaining that workload, and you know who that point of contact is. The second piece of that is you're being wise stewards of the dollars that are entrusted to you, right? So if you're actually paying for that workload and you're being a wise steward, so you're not just paying for servers that you don't need. I mean, that's something that's important, which brings you into chargeback or showback. If you don't have chargeback or showback, I'll take 1,000 servers, thank you very much, 999 for me and 1 for the bad guy. Because the fact of the matter is you're not going to be able to manage all those machines that you spun up even though you say you want them. So you really need some vehicle to charge back or show back based on your organization's mission, needs, and concerns and the way you're set up for what that actual cost is, so that there's an actual pain point. So you actually only provision the workloads that make sense to you. So the way this is set up is it's a full allocation model as opposed to as a pay-as-you-go model. So when you provision the workload is fully allocated and you pay for the entire allocation as opposed to a pay-as-you-go. Now from a budgetary perspective, when you think about that, a lot of people say, well, if you do pay-as-you-go, I'll provision a workload and I'll only pay for it when I need it, right? Okay, so today it costs me $1. That's great. I'll take 1,000 of those because it cost me $1, 999 for me and 1 for the bad guy. So, then the bad guy spins up that workload, and now you get a bill for $1,000. I said, hey, I provisioned X number of workloads, but I paid as I went. Well, you did, and he went. So that's a bad day for everybody again. So from a pay-as-you-go perspective or full allocation model, you allocate the workload. That workload is fully built and provisioned. You pay for that full allocation. From a budgetary perspective, you have a fixed cost that you can now budget for, as opposed to variable costs within your enterprise. So things to consider in deployment models. In this particular example or model, requesters are responsible for adherence to the security plan upon which the workload is instantiated. So within the secure enterprise enclave that's built and provisioned for you, you own and manage that enclave security plan, as far as the rule sets and whatnot. You have to adhere to that security plan. The requester is also responsible for full system administration and maintenance of the operating system and underlying applications. So the requester owns that box. It's no different than if they went out and physically bought a box, racked it and stacked it, put it in a data center, and provisioned that workload on there and had access to the physical power button. They have access to the virtual power button. They can mount CDs. They own that box. It's their server. It's in your cloud, if you will. So it has won some awards for this particular capability. And again, it's being re-platformed. So what you're seeing here is that provisioning workflow. So you'll see some pieces have been pulled out and are being re-platformed away from commodity or what was originally built in IOD 2.0, so we're moving this to IOD 3.0, plugging in commercial capabilities for orchestration and building some new innovative capabilities around the new 3.0 technology stack. So users log into a self-service portal. In this case, it would be yourcloud.doe.gov as opposed to what that says. You log into your cloud, you request the server. Once you request the server, you don't necessarily automatically get it. An email is sent to your responsible line manager asking for approval. This requester came in, they authenticated to the portal. They want this server for this time period. Here's the cost center that they put in. Here is the name of the server, the dollar amount, the resources. Here's your cost. Do you approve? So from it's a high governance model. So from that perspective, you can request the server, you own this server, but the fact of the matter is someone has to approve it. So it has that checks and balances thing. If you just had a requester come in and request a server and it automatically went through the process, that requester could be the bad guy. So they went in, they requested a server, and now they spun it up, and now they own it, and they're using it as a CNC vehicle to take over your enterprise. So this way you have a check and balance to ensure that someone is managing the dollars and can approve the dollars that are going to be expended to maintain that workload, and that somebody is actually looking at the requests coming in. Once that request has been approved, from that point forward, everything is automated. A workflow is kicked off to instantiate the workload. An IP address is generated. It's tied to the IPAM solution. Or MAC address is generated. It's tied to the IPAM solution. IP address is generated. That's then tied to the workload. The workload is fully instantiated. An email is sent to the user saying the workload is ready to go. Log into manage.yourcloud.doe.gov to manage your workload. So you own this workload. It's fully owned and managed by you. That whole provisioning cycle time, the time it takes to rack and stack, purchase a server, rack it and stack it, install an operating system, install applications, that entire time typically takes anywhere between 30 to 60 days. So leveraging this capability, you're moving that server provisioning cycle time from 30 days to 30 minutes. That's the agility, the power, the scalability of cloud. And this isn't just what it can do. This has been in production for several years. So with that, we have to talk about security. Because security is important in any paradigm, in every part of the architecture. You have to bake security in from the onset. Within a cloud world, within the collaboration space, within the network, security has to be baked in the design. So let's talk about security for a moment in this particular paradigm. So traditional security is typically complex. You've got multiple provisioning interfaces on the physical side. You've got overlapping administrative roles and multiple point solutions. It's typically rigid. You've got agents tied to specific workloads. Segmentation is not typically granular. It's rigid. Policies are tied to servers, and it's labor intensive. You've got to go to 3 or 4 different people to manage and maintain this thing. You've got to employ manual assessment, manual remediation of workloads. So you've got these challenges in traditional security. You need something in the virtualized space that's simple, that's adaptive, and that gives you automatic compliance. So with that said, in a physical security realm, this is typically what our workloads look like today, or our environments look like today. You've got air-gapped networks with enclaves that are segregated using hardware appliances and VLANs. So if you want to stand up a workload, you have to call 5 different people to open up all the different ports and protocols within your firewalls and VLANs to get that workload up and running. In a virtual environment, you need to take your physical security and map it to virtual security. So what we've done here is we've created these enclaves within this cloud environment and taken that a step further and created sub-enclaves for virtual desktops. And for the sub-enclaves and the virtual desktops that live in those sub-enclaves, we've eliminated lateral communication. So if a workload gets compromised, it can't go sideways. Define inter-enclave rules as to what a virtual desktop can talk to a server, and intra-enclave rules as to what a workload in one enclave can talk to a neighboring enclave. So we've made cloud security real. But that's not all. It's important to also have proactive security baked in the design. So if there is a workload that's found to be compromised, leveraging your continuous monitoring tools, you have the ability to take that workload, if it's found to be compromised, automatically offline and take it off the network, put it into a remediation enclave, give it access to remediation resources so it can be rectified before it's placed back in the source enclave. This allows you to be proactive around your security as opposed to reactive and saying, okay, who do I call? Which one of those 5 people do I call to take this workload offline? You don't have to call anyone because it's done for you. It's fully automated. It's baked into the platform. So this type of capability is something that makes cloud security real and allows you to be far more cognizant and able to really manage this environment. So now from an IOD perspective, the IOD 3.0, just doing that on the virtual side is one piece. You need the ability to manage both physical security and virtual security. So through the IOD 3.0 platform, we have the ability to manage both physical firewalls and virtual firewalls, physical load balancers and virtual load balancers, and doing all of that through a central interface so that you have all of that management and orchestration from one place as opposed to 5 or 6 different places within your enterprise. That's part of making cloud security real. You need to be able to employ all these rule sets in a place that makes sense and distribute those rule sets and manage those rule sets without having to go to 15 different places to take a look at where all that is. So with that said, we'll talk about secure hybrid cloud computing. So this is the ability to take an on-premise private cloud and connect it to a commercial cloud service provider, leveraging a secure VPN tunnel. So you need the ability to visualize resources across your on-premise customer deployed equipment and commercial cloud service provider. So leveraging this cloud service broker, you now have a single pane of glass, if you will, to look at all your resources both on-premise and commercial cloud service provider, giving you federation and choice based on the workload and the use case that makes sense for you, the requester. You also need the ability, if you have the option to, the opportunity to have this hybrid cloud in your environment, you need the ability to take workloads and move them within your environment, whether from one cluster to another, one virtual data center to the other, and maintain the same IP. Because it's not enough to just move the workload. The reconfiguration of the network is that last mile that's a lot of time and effort. So by leveraging a technology called VXLAN that was created as a joint partnership between Cisco and VMware, that capability allows you to take a workload, move it from an on-prem facility to a commercial cloud service provider, dynamically stringing virtual wires, dynamically reconfiguring a network, a layer 2 network over layer 3. So basically what that means is you have the ability to take a on-premise workload, move it over to a commercial cloud service provider leveraging VXLAN and maintain the same IP, bridging both physical networks and virtual networks in the sense of reconfiguring those networks, not bridging, but reconfiguring those networks dynamically when that workload moves. That makes cloud portability real. That makes workload portability real. These are the types of things you need to have in this environment. You need to have that orchestration framework on top of it to make all that real for you and agnostic of what that underlying infrastructure is. That's what the IOD piece brings to you. So this is IOD. This is IOD 2.0. So once the re-platform is complete and we have launched that initial operational capability, you'll see this branded as your cloud, which is IOD 3.0 on the new technology stack. So with that said, there's a green IT smart meter that dynamically computes the energy savings per year over time and puts that on a website. So this slide is a bit dated. Today it's somewhere around 2.8 million kilowatt hours of energy saved per year over time. Translate that to real life savings, and this is just the on-prem facility, just Los Alamos. So based on the amount of energy saved, at least at the time of this screenshot, Lanel can power 216 homes. So with that said, this really shows that green IT savings can be calculated and can be made real. So when we get to some of the sustained pieces, you'll see what that overall capability would look like when we show some of those architectural frameworks. So there's a dynamic cost calculator based on the amount of CPU, memory, and disk that you select and the tier of service. The cost is dynamically calculated for you. So as you can see, in this particular example, Windows Server 2008, 2 CPU, 2 gig of RAM, 80 gig of disk. At the bronze tier of service, your total cost is $134 a month. You know what your cost is before you provision the workload. You don't just get a bill and say, wait, what's that? So you know what your cost is, and someone has approved that that cost is going to be pulled out of your cost center before you provision it. So in this particular model, This is full chargeback. This is not just showback. It's full chargeback. It's integrated to a financial system, dynamic lookup of cost centers at time of entry. So when you enter the cost center, it dynamically looks up the cost center to see if it's even valid. If you don't enter a cost center, you don't get a workload. And if you enter an invalid cost center, you don't move any further. And when you actually enter it, the dollars are pulled out of your cost centers monthly. So every month there's a sweep out of your cost center into a central cost center to pay for all the services that comprise what you've selected. So with that said, full chargeback in this model is baked into the design. Once you log in, once you've created the workload, you need a way to manage the workload. So I mentioned yourcloud.doe.gov to request the server, manage.yourcloud.doe.gov to manage your server. So you go to manage.yourcloud to get a pane of glass, if you will, for administration, management, and a third tab, operations. Because you need to administer your workload, you need to be able to manage your workload, you need to look at the operations of the overall environment to see if there are issues that are pertinent to your particular workload. So this is really just a punch through here for this particular example to vCloud Director, which is the underlying piece from a technology point of view to deploy and manage the workload UI. From a management point of view, this is that pane of glass of all your servers, both on-premise and commercial cloud service provider. System name, CPU, memory, disk, total monthly cost, talked about that expiration date, that lifecycle management piece, and whether the server is active or not. So from here, you can renew systems, you can delete systems from here. You have the ability to really manage that workload holistically. Now, you also need the ability to back up your workload from time to time, and not just back up in the traditional sense, but let's say in this particular cloud environment, you want to test something, right? If you want to test something in a typical VMware environment, you go take a snapshot of a workload, and you go test something, and if it didn't work out, you revert to snapshot. How does that work in vCloud Director? It doesn't, because you can't take a snapshot. Cloud Director doesn't allow you to take snapshots. So we partnered with our storage vendor, and we created a storage-based snapshot that's vCloud aware. So that gives you two things. Number one, at the storage layer, you've created the snapshot, right? So it's no longer from a performance point of view having to write to multiple Delta files. It's the way a traditional VMware snapshot works is you take a snapshot, you have a VMDK, now you've got this VMDK.delta, right? And you instantiate all these Delta files. Well, every time you commit a write, you're writing it to all these Delta files. Then you have to roll all that up. So every time you have all these snapshots, your performance degrades. So in this particular case, by creating a storage-based snapshot, you have no performance hit, and it's fully vCloud Director aware, so when you commit that back, vCloud Director knows, okay, this is okay, off you go. So from this perspective, what we asked our storage vendor to do is write us an API. We'll write the UI. We all win. So this was really, and all of these pieces were really created as a collaboration between industry and government. Because the fact of the matter is, industry has some amazing technology. Those of you here that are from industry have some amazing capabilities. On the government side, we have needs that we have to meet for our constituents, but national labs want to push the envelope and innovate. So really, it's around creating these new capabilities to allow us to innovate together, where industry gets something new, government gets something new, and we individually couldn't have offered that, but together we can. That's how we really innovate together. So this was an example of that, along with some of the things that we did with the VMware technology stack to really get there. So there's other capabilities that partnership-wise really helps us derive and deliver new capabilities together. So from a snapshot point of view, users can log in here, they can create snapshots, they can pick machines from their drop-down box and enter the description of the snapshot. So let's talk about OneVoice. So I'm an architecture guy, so I like architecture slides. So this is, I know, a bit of an eye chart, but as an architecture guy, this speaks volumes to me. So, but really, this is around a conceptual architecture around how we see architecture, this architecture looking to us at the bronze tier of service. So from the bronze tier, on-premise, we're talking about link federation. So we have our on-premise link implementations at each one of our respective national labs and plants and headquarters, leveraging link federation to our external providers and other sites over the One NSA network. Now, we also know that within our celebrating diversity within our enterprise, we have certain labs and plants that may not have Link. So we have the opportunity through our environment to host Link in a secure Your Cloud enclave. So within the shared services enclave, having a hosted Link deployment for those sites that don't necessarily have Link implemented, they can log into the hosted Link environment. Again, leveraging Link Federation, leveraging contact synchronization across all of our sites so we have a central contact directory, and really enabling us to build this framework together. This is for that bronze tier of service. So let's talk about the next level of use case. What about full room-based VTCs? Well, we need the ability to connect you from your on-premise Link to a full-out room. Those are some of the things at the higher tier of service that will really enable us to do collaboration in a very new, innovative way. And that's part of the next level of details that you'll see as we continue some of these discussions and capabilities moving forward. So with that, I'm going to add also a piece to the puzzle in the sense that within the architecture IPT, we have 5 sub-IPTs with 5 leads within those environments. We have a one voice IPT, we have a Your Cloud IPT, one NSA network, enterprise mobility, and the 5th, which underpins them all, identity management. So each one of those teams has representatives from national labs and plants and headquarters that help develop these capabilities and really help deliver these conceptual architectures. So we're really doing this holistically and designing this holistically that meets all of our respective needs. So from a design perspective, we've got leadership across the national labs, plants, headquarters collaborating to build out these conceptual architectures in all of these 5 respective subject areas. As additional projects are onboarded, we spin up IPTs to support the same and map to cyber and policy. So let's talk about the One NSA network. So again, I like architecture pictures, so more wires and boxes. So this is an overall conceptual architecture is developed by the One NSA sub-IPT, architecture sub-IPT, and the One Voice team did the One Voice piece around what that MPLS VPN overlay looks like. So this is a connection from site to site that is an overlay across ESNet. ESNet would be is the transport for this particular network. Connected back up to Your Cloud. So each individual lab and plant gets its own secure Your Cloud enclave that is owned and managed by the lab, plant, and headquarters with sub-enclaves within those environments for workloads that make sense within their environment in a opt-in model for labs and plants and a full-in for Fed side. So with that said, each individual site has this connectivity across this network to allow us to really deliver and consume new services. Within the shared services enclave, which is shared across all labs and plants, are these new enterprise services such as all the One Voice capabilities, the social network, hosted Link, those types of capabilities live within the shared services enclave. So sustain it. So we talked a little bit about a sustain it. You heard a little bit about that this morning from both Bob and Travis. So this is now the next level of detail from an architecture point of view of the how. So boxes and wires. This is the overall, the way we see of how sustain it looks. So it's really blending 2 capabilities that were developed across the national labs. DOGRIT, the DOE Green IT solution, coupled with the Your Cloud Green IT meter. So DOGRIT really gives you data center profiling and planning. It's that DC Pro capability. Energy benchmarking, IT asset management, doing data center TCO, full sustainability project portfolio. You heard some of the business metrics that Travis was talking about, some of the project metrics, all those types of things being baked into the sustained architecture across commercial cloud data centers and on-premise data centers to deliver through a secure portal. That's really the overall conceptual architecture of how all these pieces come together. So what does this solution look like from the standpoint of capabilities? So through this portal, you have the ability to see, and this is stuff that's already baked into DOGRIT, data center high-level view of your data centers across the complex. Data center detail view, being able to see the energy consumption within those data centers. So let's say you've instantiated a workload in your environment, you have the ability to see what the energy usage is within that environment. Doing a full DC Pro analysis to determine what your PUE is in your environment baked into DC Pro as part of Sustain It. Sustainable portfolio project management, full facility TCO, and real-time energy monitoring and management, all part of the Sustain It integrated capabilities. So let's talk about mobility for a moment. So mobility is important because you need to understand that's another part of our equation. What's our challenges? Well, we have to deploy modern wireless technology, but it's hard to do in the federal government, right? You have to have a lot of different approvals in terms of to stand up these new capabilities. Customers demand new devices that they're familiar with, but show little interest in devices that we're comfortable securing. And wireless automation and connected government are years, if not decades away. So I'm going to go through the rest of the slides a little quickly because we're running short on time. So Enterprise Mobility Project does take a field of dreams approach to infrastructure, and this is really key. Really, to make mobility real, you have to make data available everywhere, yet limit where it goes. So you have to rethink mobility. And you have to think about mobility not from a mobile device management perspective, but from a mobile data management perspective, because it's not so much about securing the device, it's about securing the data. You employ the right security controls within your device, but you're really managing the data, leveraging virtualization and containerization solutions, understanding where they are, where are they, and where is the data, and what transport are they using. Are they using wireless? Are they using 3G? And how do you manage that based on understanding the data? So where are we looking to go? So from a future cycle of innovation, you heard a little bit about interactive intelligence. We're looking at taking all this great information that we have, fusing it across business, cyber, and social, and delivering contextually aware information to our constituents based on what they're doing. So if you have interactions happening from a social point of view at a time that's not normal, you can take a look at what the cyber impact might be to the same so that you can be proactive as opposed to reactive to emerging threats, which leads us to next-gen cybersecurity, being able to look ahead of where we are today, because today's best secured environment is tomorrow's cannon fodder, coupled with enabling vForce 21. All these capabilities allow us to really get to the point where we can deliver a truly mobile experience to our customers, allowing them to collaborate how they want, when they want, on a device that they're choosing in their environment. So with that said, we begin with the end goal in mind. We really want to focus on real business solutions, and we want to do it together with industry. Because at the end of the day, it's not about government delivering technology or industry delivering technology. It's about industry and government partnering to innovate together. So with that said, that's the end of my brief. Thank you very much for your time, and I'll open it up for questions.